So welcome to this video where I'm going to explain the prime factors exercise on futureskill.com. So let's dive right in here and go to the editor. So there is another exercise on the page called Sieve Eratosthenes, which is a way to get the prime numbers. So I would recommend maybe taking that exercise before the prime factors exercise, especially if you don't have some handy library where you can get all the prime numbers. But the idea here is to do prime factorization. So if we look at some examples here that we also have in the exercise, if you take the number 6, all numbers, all integers can be described in a unique way using primes. So primes, you can say, are the building blocks of all integers, and the way they are built up is by multiplication. So 6 is equal to 2 times 3. So that's a unique way to build up 6. And it's also the same independent. We have the base 10 typically, since we have 10 fingers, but primes don't have to. They would be the same even if we met another civilization on another planet. So that's nice to know. They would be discovered by probably all intelligent civilizations. So the other example that we have there on the page is, let's draw a line there. We have 3, 6, 4. So that's more challenging than 6, obviously. So how do we do the prime factorization? Well, first we can have a list of all the possible primes, like 2, 3, 5, 7, 11, 13, for example, something like that. And of course, a longer list. I guess now I have to think a little bit. Maybe we need to go to. Half the number should be enough. There is something also like square of the number, but you don't need the full list. You can go to half of 364, for example. You don't need all the primes up to 1000, of course, to do 364. But we need some list of primes. And then we see that we start with the first one, the 2 here. And we see that, 364 is evenly divisible by 2. So if we do 364 divided by 2, that is equal to 182. And then we continue from 182 here, and we check again. And we can again see that 2 is an even divider of 182. So we do 182 divided by 2, and then we get 91. And now it gets more tricky here. So we see that 2 is not an even divisor of 91. So we want to divide 91 with something. But we have to skip 2. We have to skip 3 as well. And 5 as well is not a divider. But actually 7 is a divider. So then we divide by 7. And then we get the number 13. Of course, it's 70 plus 21. And now we're getting towards the end of this exercise. 13 divided by, the next prime that we can divide with is actually 13. So in the end we get the 1 there, and then we are done. So the solution here we see in this column. This is the prime factorization of 364. It's divisible by 2, 2 again, 7, and 13. So it's notable also that a prime can be repeated. So to build up the number 364 using multiplication, we have the primes 2, 2 again, 7, and 13. So that is the prime factorization of that one. And that is what this exercise is about. So we are asked, if we look in this coding window here, to write the method get prime factors, given some integer num, which is sent in here. So there will also be another video where I show how you can solve this in Python. So the levels then, the first level, then we get these specific examples that we just looked at. 2 times 3 is 6. And in the second example of level 1, we have 2 times 2 times 7 times 13 is 364. So we will be sent 6, and then we should return a list of 2, 3. the list we return has to be sorted, and it should be in ascending order. So 2,3 is the correct response. And for level, the second example of level 1, we have to return a list of 2, 2, 7, 13 in that order. And then in the second level, which is locked for me now, then we'll have the same exercise, but we'll be given a number, random number, basically from, as it says here, from 2 up to 10,000. So 10,000 is the maximum number we can that will occur, and then we should do a prime factorization of that to pass the whole exercise. And that is the prime factors exercise on futureskill.com. Good luck!